so we'll look at the derivative of a sum. The derivative of a sum. Let f, u, and v be functions of x such that f of x is equals to u of x plus v of x. So f prime of x will be equals to u prime of x plus v prime of x. That is, when I differentiate this, I have f prime of x. If I differentiate this as well, u prime of x. And if I differentiate this, I'll have this. So f prime of x is the same thing as dy dx, and u prime of x is du dx. V prime of x is dv dx. Okay. Hence, the derivative of a sum is the sum of the derivatives. Alright. Now, that is it. The derivative of this sum is the sum of their derivatives. Okay. So find the derivative of each of the following. The first is y equals to 2x raised to power 3 minus 5x raised to power 2 plus 2. Okay, let's do that quickly. So I have that, say I have that y is equal to 2x raised to power 3 minus 5x raised to power 2 plus 2. Alright, so quickly let's solve that. It means that dy dx here will be 2 times 3x raised to power 3 minus 1 minus 5 times 2x raised to power 2 minus 1. Differentiating a constant is 0. So that dy dx now will be 2 times 3 is 6, x raised to power 3 minus 1 is 2, 5 times 2 is 10, that is 10x raised to power 1. Okay, this will give me 6x squared minus 10x. This is dy dx. Okay, let's look at the next one. B, I'm having that y is equals to 3x squared plus 1 over x. Okay, if I differentiate this now, first you know that y is equals to 3x squared plus x raised to power minus 1, because this x has a power of 1. Okay, and this 1 over now, which is the reciprocal, is minus. So dy dx will be equals to 3 times 2 x raised to power 2 minus 1. Okay, plus, if I bring that minus 1 x raised to power minus 1 minus 1. Right, so I'm having 3 times 2 are 6. Okay, 3 times 2 is 6. That is 6 x raised to power 2 minus 1 is 1. Plus times minus is minus. X raised to power minus 1 minus 1 is minus 2. So this now will give me 6x minus 1 over x raised to power 2 because of this minus sign. So that dy dx will be equals to 6x minus 1 over x raised to power of 2. Final answer. Okay, 6x minus 1 over x raised to power 2. So let's look at the next one. Look at C. C is y equals to x raised to power 3 plus 2x squared plus 1 over x. Quickly, let's solve that. So C, I have y equal to x raised to power 3 plus 2x squared plus 1 over x. So if I split them now, I'm having that y is equals to x raised to power 3 divided by x plus 2x squared divided by x plus 1 over x. Okay, and this will give me, this will be y equals to x raised to power 2 plus 2x plus 1 over x raised to power 1. Okay, as this will reduce one of these, this will cancel out 1, then x raised to power 2 will remain. So this now is y equals to x raised to power 2 plus 2x plus x raised to power minus 1. Alright, okay, so dy dx now will be, dy dx will be equals to, bring down this 2, that is 2x raised to power 2 minus 1 plus 2 x is raised to power of 1, that is 2 times 1 x, 2 times 1 x raised to power what? 1 minus 1. Abi? Then plus, bring down the minus 1, that's minus 1 times x raised to power minus 1 minus 1. Okay, so that will be, so this now will be 2x raised to power 2 minus 1 is 1 plus 2x raised to power 0, because 1 minus 1 is 0, right? Then plus times minus is minus, minus x raised to power minus 1 minus 1 is minus 2, right? So I'm having 2x plus 2 times 1, because x raised to power 0 is 1, minus the reciprocal of x raised to power 2, okay, because of this negative sign here. So this is 2x, 2 times 1 is 2. So if I bring this one by the side, this is minus 1 over x squared plus 2. Alright, final answer, dy dx is this. So this is the value we got when we differentiated y equals to x raised to power 3 plus 2x squared plus 1 all over x. Arrive at this 2x minus 1 over x squared plus 2. Okay, so let's look at the next one. Y equals to square root of x plus 1 over root x minus 3. So y now will be equals to, convert this to index form, that is x raised to power half, plus convert this one to index form, that is 1 over x raised to power of half, okay, minus 3. So that means that y will be equals to x raised to power of half plus x raised to power minus half minus 3. Okay, so this reciprocal now is negative. So I can then differentiate this at dy dx will be equals to, differentiate this now, that's 1 over 2 x raised to power 1 over 2 minus 1 plus, I bring this one down, that's minus 1 over 2 x raised to power minus 1 over 2 minus 1. Okay, I differentiate the constant, I'll have what? 0. 3 is a constant, so if I differentiate it, I'll have 0. Okay, so this now will be equals to 1 over 2, take the denominator of this is 1, so that's x raised to power, taking the LCM there, this is 1, that will be LCM of 2 and 1 is 2, 2 divided by 2 is 1, 1 times 1 is 1, 2 divided by 1 is 2, 2 times minus 1 is minus 2, okay, plus times minus will be minus, that is minus 1 over 2 x raised to power, we'll do the same thing there, you have 2 as the denominator, this is 1 here, take 2 divided by 2 is 1 times minus 1 is minus 1, 2 divided by 1 is 2, 2 times minus 1 is minus 2, okay, so I'll be having is equals to 1 over 2 x raised to power, 1 minus 2 will give me minus 1, minus 1 over 2, minus 1 over 2 x raised to power, minus 1 minus 1 is minus 3, minus 1 minus 2, sorry, is minus 3 over 2. Okay, so I write the denominator, which is minus 2, I bring it, which is 2, sorry, I bring the denominator down, so minus 1 minus 2 gave me minus 3. So this now equals to 1 over 2 times, this will be a reciprocal because of this negative there, that's the reciprocal of x raised to power half minus 1 over 2 times, this now give me a reciprocal of x raised to power 3 over 2. Okay, and finally I'll be having 1 times 1 is 1 over 2x raised to power 1 over 2 minus 1 times 1 is 1, 2 times this is 2x raised to power 3 over 2. Okay, so this is dy dx. Alright, so dy dx, finally converting that to square root, dy dx will be 1 over 2 root x minus 1 over 2 square root of x all raised to power 3. Okay, since I'm having this as 3, this 3 over 2 is something as 3 times 1 over 2, and 1 over 2 now is square root, that will be x raised to power 3. Okay, so x raised to power 3 over 2 is square root of x raised to power 3. Alright, so that's the final answer. Dy dx is 1 over 2 root x minus 1 over 2 square root of x raised to power 3. Alright, so that's the derivative of that question. Y equals to square root of x plus 1 over root x minus 3. Okay, so we'll look at function of a function. Function of a function. This is suppose we know that y is a function of u, and the u itself is also a function of x. How do we find the derivative of y with respect to x? How do we find the derivative of y with respect to x? Okay, that is, what this statement means now is that y is equals to f of u, and that u is also a function of x, which is u equals to h of x. Okay, now this means that the derivative now dy dx is dy du times du dx. Simple. So if you have that y is f of u and u is also a function of x, it means that dy dx is equal to dy du times du dx. This is called the chain rule for differentiation. So whenever you are looking at function of a function, your mind should go to chain rule of differentiation. The chain rule for differentiation is dy dx equal to dy du times du dx. We'll make use of this rule in solving questions. Now let's look at these questions. It says, find the derivative of each of the following. A, y equals to, open bracket, 3x raised to power 2 minus 2, close bracket, all raised to power 3. B, y equals to square root of 1 minus 2x raised to power 3. C, y equals to 5 all over, open bracket, 6 minus x raised to power 2, close bracket, all raised to power 3. And D, y equals to 1 all over square root of 1 plus x raised to power of 2. So let's solve the first question. Okay, let's solve the first question there. First question says that y is equal to, open bracket, 3x squared minus 2 all raised to power of 3. Okay, so you can say let u be equals to 3x squared minus 2. Alright, so that if u is equals to this, y will be equals to u all raised to power of 3. Okay, and that du dx, derivative of u with respect to x, will be equals to, differentiate this, you have 3 times 2x raised to power 2 minus 1 minus differentiating 2 now, which is a constant, you have 0. So du dx now, du dx, 3 times 2 will give you 6, x raised to power 2 minus 1 is 1, abi? So we are having that du dx is equals to 6x. Alright, du dx is equals to 6x, because 2 minus 1 is 1, x raised to power 1 is what? Is x. Now let's look for dy du. Differentiate y with respect to u. You have that dy du will be equals to, bring 3 down, minus 1 from this. That is 3u, 3 minus 1. Minus 1, okay? That means that dy du will be equals to 3u raised to power 2. Okay? Then I can then look for dy dx using chain rule. Dy dx using chain rule will be equals to dy du times du dx. Okay? So that means that dy dx will be equals to, the value of dy du is 3u squared times du dx, where du dx as 6x. Okay, so this is dy du, we had it as 3u squared, and we had du dx as 6x. Okay, so 3 times 6 is 18 x u squared. Okay, that is dy dx. So you then put the value of u, there, you have it. So if I put the value of u, I'll have that dy dx will be equal to 18x, u is 3x squared minus 2. And remember that u is raised to power of 2. Okay, and 18x 3x squared minus 2, final answer. Okay, that it implies that this u raised to power 2 So in place of this u, I put the value. The value of u is this 3x squared minus 2. So if I put it here now, that will be 18x 3x squared minus 2 raised to the power 2. Okay, let's look at the next question. The next question says y is equals to the square root of 1 minus 2x all raised to the power 3. Okay, so this now will be 1 minus 2x all raised to the power 3 all raised to the power of half. Okay, so say let u be equals to 1 minus 2x raised to the power 3. So if u is that, then that means that y is equal to y equals to u y equals to u raised to the power half. Okay, so we took u as the whole of this function. They say let u be equals to 1 minus 2x raised to the power 3. So the whole of this is u. That means u will be raised to the power of half. Okay, now du dx, let's find du dx. Derivative of u with respect to x will be equal to du dx. Now let's differentiate this. Differentiating a constant is 0 minus differentiate 2x raised to the power 3. Bring this 3 down. So if I bring 3 down, I'll be having 2 times 3 x raised to the power 3 minus 1. Okay, so du dx equals to, this one is gone, that's minus 2 times 3 is 6. 6x raised to the power 3 minus 1 is 2. Okay, so we have that as du dx. Then let's look for dy du. Dy du now will be, say, dy du will be equals to, differentiate that. I'll bring down half, bring down this half. Now I'll be having 1 over 2 times u raised to the power half minus 1. Okay, so that will be 1 over 2 times u raised to the power, the denominator there will be 2. That's LCM of 2, and this one has a denominator of 1 as well. LCM of 2 and 1 is 2. 2 divided by 2 is 1. 1 times 1, you have 1. 2 divided by 1 is 2. 2 times 1 is 2. Okay, so I have something like this. Now this is dy du. So it implies that dy du will be equal to 1 over 2 times u raised to the power minus 1 over 2. Because 1 minus 2, 1 minus 2 will give you minus 1. Okay, that's minus 1 over 2. So it implies that dy du will be equal to okay, so dy du now will be 1 over 2 u raised to the power minus 1 over 2, and this reciprocal now, sorry, the negative index will change to a reciprocal. So I'm having 1 over 2 times the reciprocal of u raised to the power 1 over 2. Alright, so that dy du will be equals to 1 times 1 will give me 1, and 2 times u raised to the power half is 2 u raised to the power of half. Alright, 2 u raised to the power half. And then this now will be using chain rule of differentiation. Okay, using chain rule of differentiation, that is dy dx is equals to dy du times du dx. Okay, so that dy dx is dy du is the value of dy du is 1 over 2 u raised to the power of half times du dx. Du dx is minus 6x raised to the power 2. Okay, so this now is equals to 1 over 2 times u, the value of u. Remember, we had the value of u as u is 1 minus 2x raised to the power 3. That's u. So we take this thing out now for u. 1 minus 2x raised to the power 3. As in place of u, I'll write 1 minus 2x raised to the power 3 all raised to the power of half minus times minus 6x squared. Okay, so this now will be 1 times minus 6x squared is minus 6x squared divided by 2 open bracket 1 minus 2x raised to the power 3 all raised to the power half. Okay, and 2 here, 1. 2 into 6. 2 into 6 is 3. This is dy dx. So we're having that dy dx, value of dy dx now will be equals to minus 3x raised to the power 2 all over 1 minus 2x raised to the power 3 all raised to the power of half. Okay. Final answer is this. Okay, so dy dx is minus 3x raised to the power 2 all over 1 minus 2x raised to the power 3 all raised to the power half. Okay, so 2 going to 2 is 1, 2 into 6 is 3. That's how we arrive at this final answer. Okay, final answer. Let's look at the next question. Okay, so the next question, C. Question C now, it says y equals to 5 all over open bracket 6 minus x raised to power 2 all raised to power 3. Okay, so this is equals to y equals to 1 over 6 minus x raised to power 2 all raised to power 3 times 5. Okay, so the reciprocal now will change to negative index, so that y will be equals to 6 minus x raised to power 2 all raised to power 3, sorry, raised to power minus 3 times 5. Okay, so I'm having that y is equals to 5 open bracket 6 minus x raised to power 2 all raised to power minus 3. Okay, then we say let u be equals to 6 minus x raised to power of 2. Alright, that means that y will be equals to 5 u raised to power minus 3. So it means that everything here has been represented with what? U. And then the expression will change to y equals to 5 u raised to power minus 3. Okay, so find du dx. Du dx, that is the derivative of u with respect to x, will be equals to differentiate 6, which is a constant, you have 0, minus differentiate x squared, you'll be having 2x raised to power 2 minus 1. As you bring to the minus 1 from this, okay? And 2 minus 1 is 1. So having that du dx will be equals to 0 is nothing, minus 2x. Okay? Now let's find dy du. Dy du. Differentiate y with respect to u. Yes, dy du now will be 5 times minus 3 u raised to power minus 3 minus 1. Okay? As you bring down this minus 3 down, the minus 1 from it. So we're having 5 times minus 3 is minus 15. U raised to power minus 3 minus 1 is minus 4. So I have that dy du. Dy du finally, dy du will be equals to minus 15 times 1 over u raised to power 4. And I'll have that, now we'll be having that dy du will be equals to minus 15 over u raised to power 4. That is minus 15 u raised to power minus 4. This negative there changes to a reciprocal. Minus 15 times 1 gives you minus 15. That will be minus 15 over u raised to power 4. That's dy du. Using chain rule differentiation, you have that dy dx is equals to dy du times du dx. So that dy dx because to dy du there is minus 15 over u raised to power 4 times du dx. Du dx is minus 2x. So now we're having that dy dx is equals to minus times minus is plus. Okay, prior to that time, let's look at this. That dy dx will be equals to minus 15. Put the value of u, please. Impute the value of u here, and you will have the value of u is 6 minus x squared. So let's put it there. So I'll be having what? 6 minus x squared all raised to power of what? 4. All raised to power 4 times minus 2x. Alright? So this is minus times minus is plus. So that means that dy dx is equals to 2 times 15 is 30. That is 30x all over 6 minus x raised to power 2 all raised to power 4. Final answer. That is it. That's the final answer for that. The dy dx is 30x over 6 minus x raised to power 2 all over all raised to power 4. Okay, let's solve the next question. The next question D. Question D says y is equals to the reciprocal of the square root of 1 plus x raised to power 2. Okay, so this now is similar to saying the reciprocal of 1 plus x raised to power 2 or raised to power of half. Okay, which means that y is equals to 1 plus x raised to power 2 or raised to power minus 1 over 2. Alright, okay, so that is it. Now I can say let u be equals to 1 plus x raised to power of 2. So I represent the whole of this with what? U. Now that means that y will change to, so that y now becomes u all raised to power minus 1 over 2. Okay, that's the value of y. So let's find du dx. Du dx now will be equal to, remember that I had what u as 1 plus x raised to power 2. So differentiate this now. Differentiate 1 is 0. And differentiate x raised to power 2 is what? 2x raised to power 2 minus 1. So that du dx will be equal to, differentiating this now, we had 2x raised to power 2 minus 1, which is 2x raised to power 1. Because 2 minus 1 is what? 2 minus 1 is 1. So I have that du dx is equals to 2x. X raised to power 1 is x, right? And we can find dy du. Dy du will be equal to, now we remember we also had the value of y as, okay, u raised to power minus 1 over 2. Okay, it's over here. We had y as u raised to power minus 1 over 2. So we can then differentiate this. Differentiate y now with respect to u. Differentiate it with respect to u. So you'll be having minus 1 over 2 times u raised to power minus 1 over 2 minus 1. Okay, so you minus 1 from it. You bring the minus down, minus half down. Okay, so I'll have that dy du will be equals to minus 1 over 2 times u raised to power, this one has a denominator of 1, so the sum of 2 and 1 is what? Is 2. Okay, so 2 divided by 2 is 1, 1 times minus 1 is minus 1, 2 divided by 1 is 2, 2 times 1 is 2. So I'll be having what? That dy du is equals to minus 1 over 2 times u raised to power minus 1 minus 2 is minus 3. Minus 3 over 2, isn't it? Okay, so I have minus 1 over 2 times, if I take the reciprocal, now that is 1 over u raised to power 3 over 2. Okay, this is dy du, and that dy du now will be equal to minus 1 times 1 is minus 1, 2 times u raised to power 3 over 2, okay, is the value of dy du. So I can then use my chain rule of differentiation. Chain rule now states that dy dx is equals to dy du times du dx. Okay, that's chain rule of differentiation. Then I put the value of dy du here, and that of du dx, which is 2x, I'll put it there. And so I'll have this, so that dy dx is equals to, the value of dy du is minus 1 over 2u raised to power 3 over 2 times, so I can then put the value of du dx. Du dx is 2x. So this now equals to minus 1 over 2 times, put the value of u. The value of u there is 1 plus x squared. That is 1 plus x squared all raised to power 3 over 2 times 2x. So this will eliminate this. And so I'll be having minus 1 times x, give me minus x all over 1 plus x raised to power 2 all raised to power 3 over 2. This is dy dx. Okay, final answer. So dy dx there is minus x all over 1 plus x raised to power 2 all raised to power 3 over 2. So we saw how we did the arithmetics. We got to this point, we came here, we had to put the value of u here, and we had the value of u as 1 plus x raised to power 2, so I had to put it. So I have to put it there. In place of in place of u, I put 1 plus x raised to power 2, or raised to power 3 over 2. So 2 we cancel 2, and then we have minus 1 times x will give you minus x. Final answer is this. Alright, we have come to the end of this series of differential calculus. We stopped at function of a function, which involves the use of a chain rule of differentiation. Okay, in the next class we'll continue. Thank you. Bye for now. Thank you.